You're watching the Weiss channel. So we're going to do factoring trinomials part 2. In part 1, we said x squared plus 9x plus 20. Factor this. Well, what times what makes x squared? X times x. And then what times what makes 20? Well, 1 times 20, negative 1 times negative 20. 2 times 10, negative 2 times negative 10. 4 times 5, negative 4 times negative 5. All of these combinations multiply to make positive 20, but only one of them adds to make a positive 9. Which one is that? 4 and 5. So my answer is x plus 4, x plus 5. Okay? Now, in these problems now, there is a number before the x squared. Oh, that's a whole new ball of wax. Well, in this case, not only do we need to know what times what makes 12, but we need to know what times what makes 6. So what times what makes 6? Well, 6 times 1 or 3 times 2. Okay. And what times what? Since this is positive and positive, it's going to be positive numbers. So it's either 12 times 1, 1 times 12, 6 times 2, 2 times 6, 3 times 4, or 4 times 3. So we're just going to start playing around a little bit. I always start with the ones that are closest together, meaning if I have between 6 and 1 and 3 times 2, I always pick the 3 times 2 first, the ones that are the numbers that are closer together. Why? I'm not sure, but it seems like more often than not the answers contain 3 and 2 as opposed to 6 and 1. Now, what times what makes 12? Okay, so we're going to pick one. And again, I pick the ones that are closest together, like 3 and 4. Now what's going to happen is 3 will not be here because you're not going to have the same number in the same set of parentheses. In fact, not only will you not have a 3, you won't have a 6 or a 9 or a 12, any multiple of 3 either. The same goes for 2. You won't have a 2 or a 4 or a 6 or an 8 or a 10, any multiple of 2 in there. Okay? So I'm not going to put the 3 here. I'm going to put the 4 here, and I'm going to put the 3 here. So now I know I made 6x squared. I know I made 12. The question is, did I make 17? And you have to check by doing the O and the I, the outer and the inner part of FOIL, right? So we're going to do 3 times 3 is 9, 4 times 2 is 8, and 8 plus 9 is 17. Ding, 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 ding. That's my answer. Okay. Over here, 7x squared plus 23x plus 6. This is nice because 7, there's only one possible way to make 7. It has to be 7 times 1. And I'm just going to say 7 times x. What times what makes 6? Well, 6 times 1 or 3 times 2 or 2 times 3 or 1 times 6. Okay. So 7 times 1, all right, I could try 3 times 2, right, and see what happens. In fact, what if I did that? What if I did 7x plus 3 times x plus 2, okay? Now I gotta try. 7x times x is 7x squared, and I know that 3 times 2 is 6, but the outer here, 7 times 2 is 14x. The inner, 3 times x is 3x. 3x plus 14x is 17x, but I need 23x. So if 3 and 2 doesn't work, what if I try putting 2 here and 3 here? And that's what I do. If I put 2 here and 3 here, now the outer is 21 and the inner is 2. And I get 23. Ding, 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 ding. That's my answer. Okay? Now, here, 4x squared plus 4x minus 15. The first thing I'm going to try is 2 times 2 for 4. And then I'm gonna do 5 and 3 for 15. Now, because this is negative, I need a positive and a negative. All right, have a good day, say no to drugs. Okay, so a positive and a negative, and I've got a positive 4x. So look, the outer here is -6, and the inner is +10. I need the bigger number to be positive. So I'm going to take the 5, make the 5 positive and the 3 negative, which will get me a positive 4x. Ding, 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 ding. Over here, 12x squared plus 1x minus 6. I'm going to try 4 and 3 first to make 12. And I'm going to try 3 times 2 for 6. All right. Now, if I put in 3 and 2, you'll see that I get it. 4 times -2 is -8. 3 times 3 is +9. And +9 minus 8 is +1. Ding, 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 ding. Over here, 4x squared minus 19x plus 12. I'm going to start out trying 2 times 2. All right. 4x squared minus 19x plus 12. I'm going to start with 2x times 2x. All right. And for 12, all right, if I try 3 times 4, 3 times 4, this is not going to work because you're not going to have a multiple of 2. All right, so I can't put the 4 here or here. All right, so what about 6 and 2? Well, that's not going to work because you won't have a 2 here, you won't have a 6 here, so no go there. What about 12 and 1? That won't work because that's also a multiple of 2. You're not going to have that either. So 2 times 2 is not going to work. So I'm now going to try 4 and 1. 4x and x. And now I'm going to start with 3 times 4. All right? Because this is positive, I need a negative times a negative because that guy is negative. So if I try -4 and -3, I'll find that that won't work. So I'm going to flip the 3 and the 4. I'll put the 3 here and the 4 here. And by the way, I can't put 4 here because 4 and 4 will never be in the same set of parentheses. So I'm going to put 3 here and 4 here, and I will get -16 and -3, which makes -19. Ding, 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 ding. And there's my answer, 4x minus 3 times x minus 4. In general, with these problems, if 3 and 2 doesn't work, try 2 and 3. Now, it wouldn't work in this case, but just try it when you're not sure, okay? You've been watching the Weiss channel.